Hi, I thought I'd just do a quick demonstration of some apparatus that we've got here that I know some of you will have looked at during the lesson, but not everyone will have had the chance. I wanted to make sure that you understood what was going on so that you could answer the question that we're giving you later on. So let me describe what apparatus we've got here. Here on your left there's a microwave transmitter, and over here we've got a receiver, and the receiver is connected up to the oscilloscope, and you can see that at the moment there's a nice square wave being shown as that receiver is receiving the signal from the microwave transmitter. Now here's another piece of apparatus, just a piece of metal attached to a wooden block. Now have a look at what happens when I put this metal in between the transmitter and receiver. Can you see the size of the signal over there has got significantly smaller? Now if I can explain what's going on here, there is a wave going from the transmitter to the receiver, but also some of the wave is being reflected off the metal plate. Now an interesting feature happens whenever a wave is reflected off something. It always goes through a 180-degree phase change, which means that the wave that is going directly to the receiver is in antiphase with the wave that is being reflected, which means that at this point here we've got virtually a zero signal on there. Now here's the bit that the question will be asking you about. Watch what happens when I move this metal plate away from that centre line between the transmitter and receiver. Can you see what's happening there? The signal is getting bigger and bigger. Oh, hang on, it's getting a bit smaller now. And then it's getting bigger again and smaller. So let me go back to this point here. Remember at that point there, the two waves, both the transmitted and the reflected wave, have got exactly the same path length, but they're 180 degrees out of phase, which means that we're getting destructive interference at the receiver. Now, if I move it to this point here, again you can see the signal is quite small. There are two questions that I'd like you to think about here. The first one is trying to explain why it is there is a minimum at this point here. Think about the two waves that are travelling, the one that's directly transmitted and the one that's reflected. The second question is now answering the question, why is it now, even though this is at a minimum, that this signal is not zero? Okay, I hope you understand what the question I'm asking there. Have a look at the question on the exam paper and see if that makes some more sense. Bye.